Hello everyone. Today we will continue to look at the content of HCI-Storage. Previously, we have already covered mechanical hard drives and solid-state drives, the two main directions. Next, we will finally learn about a new and recently introduced type of storage. That is the SEM card. In full, we can call it storage class memory, or it can also be referred to as non-volatile memory. From the name, its primary characteristic is related to memory. Firstly, its speed is slightly slower than that of memory. But what can it achieve? It can achieve a storage effect. For regular memory, what can we normally do? We can only use some data in the memory when the computer is on, right? For example, when you turn off your computer, the data in the memory is actually deleted. Of course, some of it can be saved to the hard drive, but the rest will actually be deleted. So, although memory is very fast when we use it, it cannot truly store data like a hard drive can. This kind of card is actually what we call a new type of host memory. It is actually a cache acceleration card of the SM media type. It is a cache acceleration card, and its speed can approach that of memory. Additionally, it can achieve the effect of storage as well. Simply put, the data stored in SCM will not be lost when the power is cut off. This is the difference between it and the most common volatile memory. Normally, with volatile memory, once the power is cut off, the data will disappear. In ordinary cases, once the power is cut, any new data will instantly vanish. So our SCM card's most crucial feature is its non-volatility, which provides strong assurance for data security and reliability. From a performance perspective, the access speed of our SCM is very fast, just slightly slower than traditional memory. It is far faster than the flash memory types, much faster. We can use an analogy here. If we consider the process of data storage and retrieval as a relay race, memory is like the fastest sprinter, able to transfer data in an extremely short time. So what about flash memory types? They are actually like long-distance runners, relatively slower in speed but with greater endurance, yet capable of storing large amounts of data. And it is in between the two. It has both decent speed and a certain data storage capacity, like an all-around athlete. In the process of modern data handling, for scenarios that require high speed, but not the extreme speed of memory, we actually become an ideal choice. First, let's take a look at the SM card itself. It is a cache acceleration card based on SM media. Here, when we mention cache acceleration, what concept are we referring to? It is equivalent to adding a power accelerator to the data reading and writing process. Now, current situation. In the case of the all-flash version, within the all-flash storage version, for example, when we use the Smart Cache feature, we need to install the SM card on our control frame. Smart Cache is actually an intelligent caching technology. It can place frequently accessed data into high-speed cache based on the frequency and heat of data access to respond to read requests more quickly. And the SM card, as an important component of the Smart Cache feature, with its fast access speed, can greatly enhance the performance of our entire storage system. Well, for example, in a company's database application, there are a large number of user requests, right? Frequent data reads and writes are needed. Without the card's acceleration, the reading and writing of data might become very slow due to the speed limitations of the storage medium, leading to a decline in user experience. However, after installing the SM card, those frequently accessed data can be quickly processed in the SM card's cache. This greatly improves the detailed speed of our database, allowing users to use our application system more smoothly. If we delve deeper into our SM storage memory as a new generation of storage medium, it actually has one or two characteristics of persistent fast access, providing a much faster read and write speed than flash memory. This makes it suitable for many performance-demanding scenarios. Well, it will have a broad application prospect. For example, in the field of big data analysis, wave data needs to be stored and read quickly to enable real-time analysis and processing. The fast access feature of SM can well meet this demand, greatly shortening our data processing time and improving analysis efficiency. There are actually many types of SM media. First, we will introduce this to everyone. The types of SM media. First, the first type. The first type, PCM. It is a phase change memory. The working principle of phase change memory is to use the phase change of materials to store data. Under different temperature and current conditions, phase change materials can switch between crystalline and amorphous states. These two states actually correspond to what? They correspond to our data's 0 and 1. Although it sounds somewhat complex, right? But in fact, it's just 0 and 1. These two states actually represent the 0 and 1 of our data, and it has the advantages of high speed and high reliability. In scenarios where there are higher requirements for storage speed, its application value is relatively widespread. The second type is MRAM, which is magnetic random access memory. MRAM uses the direction of magnetization in magnetic materials to store data. Its advantages are fast read and write speeds, low power consumption, and it has non-volatility, meaning data is not lost after power is turned off. In devices that are sensitive to power consumption, such as mobile devices and IoT devices, it has significant application potential. Because for mobile devices and IoT devices, our demand for power is actually quite small, relatively speaking. The requirements for power consumption are quite high. If your power consumption is very high, for example, take mobile devices like smartphones as an example. It's very straightforward. In your phone, right? The battery can only store a limited amount of power. And since the phone itself isn't large, even if the battery is highly compressed, it still can't store much power. This makes it very suitable for low power devices. The third type, it's STT-RAM. It is a spin transfer, torque random access, memory. It stores and reads data based on the spin properties of electrons, offering high storage density and fast read speeds. In the future, in the field of high density storage, this STT, it might play a bigger role in the future. Currently, it's not widely used. The fourth type is FERRAM, which is ferroelectric memory. It uses the polarization properties of ferroelectric materials to store data, characterized by fast read and write speeds and strong radiation resistance. In some special environments, such as aerospace and military fields, it is applied quite well. As for ferroelectric memory, it actually utilizes the polarization properties of metal materials. The fifth type is RAM, which is resistive random access memory. RAM changes the resistant state of materials to store data. To summarize, regardless of the type of material, each of these materials actually has slightly different principles, because the materials used are not quite the same. For example, some use static materials, and others use dielectric materials for polarization, some use resistance, and others use magnetic materials, etc. Regardless of the type, ultimately, we just need to represent what? Represent the two types of data, 0 and 1, that's all. Diameter or non-diameter, right? Between static and non-static, as long as you have 0 and 1, it can actually store data. So here, actually, with different structures, ultimately, the principle is the same. It's about representing data with two different states, 0 and 1, which allows for data storage. If the conversion speed is faster, generally, the access speed is also faster. Here, we are talking about some characteristics of these different materials. This is the main content of our card. To sum it up, in one sentence, the future is promising. Currently, the fields of application are not particularly numerous, but it is something to look forward to in the future. As for storage, currently solid-state drives and mechanical drives are used more frequently. In the future, there will actually be more applications. If anyone wants to learn Huawei certification technology or obtain Huawei certification question banks, please send me a private message, or you can leave a comment below the video for technical exchanges. That's all for today.